Welcome to the last video of Section 4, Managing User Preferences. In the previous video, we have learned how to make the game functional. In this video, we'll learn how to manage user preferences. A very common theme in several GUI programs involves letting the user set the program's preferences. For example, what if we want users to be able to customize the chessboard colors? What if we want users to select colors and once selected, it is saved as a user preference and it is loaded the next time the program is run? Let's implement this as a feature. Python offers a standard module called Config Parser that lets us save user preferences. Let's see the Config Parser module in action. To begin with, import the Config Parser class from the Config Parser module in the configurations.py file. The Config Parser module uses the ini files to store and read the configuration values. The file consists of one or more named sections. These sections contain individual options with names and values. To illustrate this, let's create a file called chess_options.ini in the project's root folder. The file looks like this. The first line of the file enclosed in square brackets is called a section. An ini file can have multiple sections. This file has a single section. Each section can have multiple key value options as specified in this example. We can read these values in our program by using the getter methods. This code replaces the three color constants that we defined earlier in the code. Now, if you change the options in the ini file, the color of the chessboard changes accordingly. However, we cannot expect end users to be conversant with editing the ini files. Therefore, we will let them choose the colors using the Color Chooser module of tkinter. A color that a user chooses gets reflected in the C file, and consequently on the chessboard. When a user clicks on the Edit Preference menu item, we want to open a transient window with three different buttons to choose two chessboard colors and one highlight color. Clicking on a single button opens a Color Choose window. We created this transient window in a new file called preferenceswindow.py. We will not discuss the code that creates this window, as this should be an easy task for you now. Note that this window is converted into a transient window with respect to the top-level window by using this code. As a reminder, a transient window is one that always stays at the top of its parent window. It gets minimized when its parent window is minimized. As we have created the window in preferenceswindow.py, we'll import it into the View class. Then, command bind the preference menu by using the following two methods. When a user clicks on the Cancel button, we simply want the settings window to close. To do this, use this code. When a user changes the colors and clicks on the Save button, the method calls the set_new_values method, which first writes the new values to the ini file and then returns the values to the View class to immediately update the chessboard. When this code writes the new NSW values to the ini file, call the reload_colors method from the View class to immediately update the chessboard's color. If you do not do this, the color change will take place the next time the chess program is run. Having changed these attributes, we call draw_board and draw_all_pieces to repaint the chessboard in the newly defined colors. This concludes the iteration. Thus, the users of the program can change the colors to match their preferences, and the program will remember the chosen values. Awesome! We have successfully learned how to manage user preferences. This video concludes the fourth section of this course. We have come to the end of this section. So, what is it that we achieved here? Let's have a look at all the key things that we learned from the section. We learned how to structure programs using the MVC architecture. We took a peek at the versatility and power of the tkinter Canvas widget. This included a tour through the basic usage of the Canvas coordinates, object IDs, and tags. We discussed how to handle complexity by implementing programs in a modular structure. We achieved this modularity by breaking down the code into several smaller files. We handled the entire configuration from a single file and all the errors in another file. We explored how to extend Python's built-in error class to define a custom error and exceptions. We also had a look at how we can extend Python's built-in data types, like in the case of the model class, which directly extended the dict class. We studied how to use object inheritance to code classes with similar attributes and behavior, when building the piece class and all its subclasses. Finally, you learned how to use Python's built-in config parser module to store user preferences. In the next section, we will create an audio player in the next chapter. In addition to this, we'll work with several new widgets. We'll also take a look at how to create our own widgets.